So here's an exciting math question. It comes up in Calc BC, but almost anybody can handle it. This is a very easy, here's a very exciting proof about this series called the harmonic series. So guys, the harmonic series, this symbol means take the sum from 1 to infinity of numbers of the form 1 over n. So what that means is this symbol is the Greek letter sigma, just means make a bunch of additions. So put a 1 in here, you get 1 over 1, plus put a 2 in, 1 over 2, plus put a 3 in, 1/3, plus 1/4, plus 1/5. Well, that's a nice 5. Plus 1/6, plus 1/7, plus 1/8. I was trying to tell my 12-year-old about this series, but he wants to play some video games. How peculiar. Anyways, I think he could handle it if I could get his attention, but all you teachers out there know, try to teach your own kids. Anyways, so if you add 1 plus a half plus a third plus a fourth plus a fifth, the question is what happens when I add this up? Does this converge? Converge means settles down to some finite number, or does it diverge? Does it grow towards infinity? And so the way you prove what this does is you compare it to another series of numbers. I'm going to write the series below there. So let's look at a series comprised of 1 plus a half plus 1/4 plus 1/4 plus 1/8 plus 1/8 plus 1/8 plus 1/8. Does anybody notice a pattern of what these numbers are summing to when we add them up? 1/16, 1/16. Just got to write 4 more. 1/16, 1/16. Plus dot dot dot. So the bottom sum is the number 1 plus a half on 1/4 and 1/4. That's plus 2/4 plus 1/8. 1, 2, 3, 4 times 4 over 8 plus 1, 2, 3, 4, 5, 6, 7, 8/16. So if you look, there's no reason we'd have to stop the pattern in blue. 1 plus a half plus 2/4 plus 4/8 plus 8 over 16. After that, we could do 16 over 32, then 32 over 64, and keep going forever, okay? And you're like saying to yourself, self, what's that got to do with the top series? And here's what it has to do with it. So the bottom series, we have 1 plus a half plus 1/2, 2/4, plus 1/2 plus 1/2 plus dot dot dot. So if I have a series where I have 1 plus a half forever, clearly this series diverges, grows infinitely large. And so what we're going to do is directly compare it to the series above it. And you say, this term is the same as this one's the same as this one's the same as this one is equal to this, and this one equals this. And what about the lined up terms? On the top we have 1/3, which is bigger than 1/4. 1/5, 20%, is bigger than 1/8, 0.125. 1/6, 0.16 repeating, and so forth down the line. 1/7 is bigger than 1/8. Over here we've got 1/9, 0.1 repeating. 1/16 is 0.0625. So if you do the decimal equivalents, I think you'll convince yourself that every one of these numbers in red exceed the number below them. So what do we have here? In green we have a series of numbers where you're adding 1 and then a half infinitely, so it's going to diverge. And the series on top is either equal to the divergent series or it exceeds it. So you have a series that's equal to or greater than a divergent series. So then we say, therefore, we used to use that in engineering school, the series from n equals 1 to infinity of 1 over n, the harmonic series diverges. And have a good day.